This week, we speak with Adam Hughes from Scilabs, and then we speak with Utsav Sangani from Synopsys. Yes, it's a week with two interview segments. We'll cover containers, coding, and creating tools that DevOps teams want to use. Stay tuned for Application Security Weekly.
This is a Security Weekly production. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly. As the world of software-driven everything becomes a reality and development cycles speed up, sales teams are taking a new approach to application security, one that enables security teams to scale by empowering developers to integrate security into their development workflows and tool sets, all while giving security teams the visibility and control they need. Snyk helps software-driven businesses develop fast and stay secure with a developer-first solution that seamlessly and proactively finds and fixes vulnerabilities in open-source libraries and containers. Learn more and see the solution for yourself at securityweekly.com/Snyk. Nearly every business today relies on mobile applications, yet the vast majority do not adequately secure them. Once downloaded, mobile apps escape your control outside the secure network perimeter, thus making them easy targets for hackers. Enter GuardSquare. From the makers of ProGuard, GuardSquare integrates transparently and seamlessly into the development process, adding multiple layers of protection to Android and iOS applications, and effectively hardening apps against both on-device and off-device attacks. Request a demo today of GuardSquare at securityweekly.com/GuardSquare. The question is simple. Have any of the systems on my network been compromised? The answer is harder than it should be. Enter AI Hunter. Active Countermeasures has automated and streamlined techniques used by the best pen testers and threat hunters in the industry to create AI Hunter, a network threat hunting solution that does the first pass of a hunt for you to identify systems that are most likely to be compromised and scores the results on a scale from 0 to 100. You can then research those systems in depth with AI Hunter. Focus your valuable time on the systems that need your expertise with AI Hunter. Sign up for a personal demo today at securityweekly.com/ACM.
Welcome to Application Security Weekly. This is episode 101, recorded March 23rd, 2020. I'm your host, Mike Shima. I'm here with Matt Alderman. Hey, Matt.
Good morning. I'm in an undisclosed location, not my normal studio. Sorry.
I was going to say, a little bit of a different background. I can't guess where quite you are. But we won't give it away until maybe the very end. So sorry, listeners, you have to listen through both segments, and maybe we'll reveal. But we've also got John Kinsella here. Hey, John.
Hey, guys. I'm at this location with my little bit of sun still over my head. So.
It looks like a hat. It looks so good on you.
We'll take it for now.
InfoSec World 2020 was originally scheduled for March 30 through April 1st, 2020 at the Disney Contemporary Resort. This conference has been rescheduled for June 22nd to 24th due to COVID-19. Security Weekly listeners still save 15% off the InfoSec World main conference or World Pass. Visit securityweekly.com/ISW2020. Click the register button to register with our discount code or the schedule button to sponsor a micro interview. Cybersecurity Exchange Day, hosted by Ocean and the Pell Center, was originally scheduled for Wednesday, March 18th, and has currently been postponed. New date is still TBD, and we will keep you posted as soon as we hear more. Adam Hughes is a developer with nearly 2 decades of experience in cybersecurity, real-time operating systems, carrier-grade telecommunication systems, and large-scale distributed systems. After joining Scilabs in early 2018, he helped develop the Singularity Container Services Suite, which forms an ecosystem around the Singularity Container Runtime. He has since taken on the role of Chief Software Architect and is now responsible for technical leadership of all Scilab products. Hi, Adam. Thanks for joining us.
Hey, great. Glad to be here.
You have come into containers and container security from, I think, a very different path than other people we've talked to, and a pretty interesting path coming from HPC. Let's start off by just telling us a little bit, how did you get into containers, or what was this path like getting to this point?
Yeah, for sure. So my path to containerization, I guess, really started, like a lot of people, with Docker. I was working for the Canadian government at the time, doing sort of InfoSec type stuff, cybersecurity type work. And then a colleague of mine who had recently left gave me a shout and said, hey, there's this really interesting technology, alternate container technology that's in the HPC space that looks really interesting from a security point of view. And that's really what got me interested from the start.
And already from that start, though, high performance computing, that environment has got to be a little bit different from the cloud or data, call it quote unquote standard data center computing. What were some of the interesting things that you encountered there, just in terms of scale or performance? And where I'm leading with this is, how did also that start to inform the way you approached containers?
Yeah, for sure. So for Singularity, this starts a little before my time at Scilabs, but happy to share the background. So really, Singularity starts with our CEO, Greg Kurtzer. Greg has a long history of meaningful contributions to open source. He founded the CentOS Linux distribution, probably the most prevalent of those. And then in 2015, Greg was working at the Lawrence Berkeley into a format. And really what they were asking is to install Docker on an HPC system. So Greg was, systems architect at Berkeley. He was sort of in charge of implementing that. Took a deep dive into Docker and really found that, that the usage model and the security model of Docker wasn't really compatible with an HPC environment. One primary thing about HPC environments is that they're multi-tenant. So, they have a lot of sensitive data information, such as health information, intellectual property, and even classified information. And in HPC environments, this information is housed typically on shared storage and protected by, traditional POSIX permissions. So in that context, looking at Docker, really when you grant a user access to run containers with Docker, you're granting them access to a root-owned daemon that can do certain things on their behalf. Those include mounting arbitrary file systems into the container and then allowing the user to dictate which user they are inside that container. So when you couple that with the data model, really, there wasn't a great deal of compatibility there. And that's really where Singularity came out of. Greg said, this technology, containerization, obviously has promise, and there didn't seem to be a runtime out there that met this need. So he decided in his own time to start working on Singularity.
You know what, Adam, could you for a second, I suspect a lot of our listeners don't have a really good sense of HPC. Could you maybe talk a little bit, maybe, I don't know if you have like an example off the top of your head of one of your guys' users of like what type of workloads they have, sort of the mixture of workloads, and then the actual scale of the size of that installation?
Yeah, for sure. So I mean, you touched on one of the big pieces there, scale. So a lot of times, the jobs that are being run in these centers are being run in a supercomputing environment, and really that's about, in many cases, about parallelization. So rather than taking one process on one machine and trying to make that go faster, some of these problems that are being solved at these centers just can't be tackled in that fashion. So what they do instead is that they end up having hundreds or even thousands of processes across hundreds or thousands of nodes that all need to communicate and all need to coordinate. So there's technologies involved like MPI that's the mechanism by which you do this very parallel processing. So I mean, some of those are, the architecture sort of falls out of that. So on the storage side, for example, shared file systems are very common between all these nodes. You have things like batch schedulers that manage starting all these processes at the same time, coordinating kind of their wire up and that sort of thing. So quite different from traditional computing, even traditional distributed computing. A little bit of a different approach there.
I think what I was looking to call out there, again, it's on the security side, is for, at least with my HPC background, you might have it's almost like an internal. Well, it depends on where you are, I guess. I'm thinking from a university point of view, and Paul might have this background too. But from the point of view of you're almost acting as a service provider inside to the community. So while the average, I'll say, researcher might not have completely separate logins and credentials. They have this job they want to run, but you might have, say, like an earthquake simulation going on at the same time as maybe something for a DoD grant, at the same time as something for maybe corporate funded research. So that's where I'm thinking from the point of view there's multiple, what could be very expensive jobs happening with large amounts of money behind them that you still have a concern from a security point of view.
Yeah, for sure. I mean, all of these environments, the cost to set up a supercomputer is just astronomically high, and as a result, bringing in workloads from as many places as they can, and you end up having a lot of sensitive workloads that are happening right beside each other. So it is truly a multi-tenant environment in that sense. Yeah.
And thus the importance of isolation of data and compute and some of the other things that started you down this path with creating a unique approach to containerization in this environment, in this architecture.
Yeah, exactly.
Yeah, I think that's because there's also that data segmentation, and there's also even just the performance, because running containers, people say they're running containers at scale, but that may be for web application type of architectures. In this, it sounds like there's some additional constraints, both on, already you mentioned, I bet Matt's ears perked up, not giving up root inside the container or not running as root, but also even just spinning up, hundreds or more likely thousands of containers all working on a problem. That's got to be expensive, and that's also got to be a performance area of focus too, let alone just the security of how these images are accessing information or being prevented from accessing information, for that matter.
Yeah, for sure. So security has been paramount from the start for us. Really, what that means kind of philosophically is that when I log into an HPC system and run a job as myself, inside that container, I should only be able to do things that I'm allowed to do normally outside of that container. So what that doesn't mean, though, is it doesn't mean isolation from the host. This is another area that's quite different in HPC. Often when we talk about security, it's about isolating host resources when you're inside a container. But actually, in high performance computing, you may need to leverage GPUs or FPGAs or even high-speed interconnects just to get your work done or to get it done effectively. So we kind of have this dual model where we're very focused on providing low overhead, providing direct access to those hardware resources, but doing so in a way that respects the security model of that environment and allows sensitive workloads from different tenants to be run on the same machines directly beside each other.
So Adam, I'm curious, are you running the containers directly on the host? You're not using like an orchestrator to orchestrate these containers, are you? Because that would add a layer of abstraction that wouldn't help you from a performance perspective?
Yeah, so in high performance computing, typically you have a job scheduler. So a little bit different from an orchestrator, in the more cloud native kind of world. Really what a job scheduler is focused on doing is getting those jobs running and maximizing utilization of that system. So it's really about throughput, whereas that you have to do in order to do that is that scheduler has to be able to control the system. So, with other container runtimes, when you run a container, what actually happens is you're talking, well, with Docker at least, you're talking to a daemon that's then spawning off a process on your behalf. With Singularity, we're really just spawning a process directly into namespace, and that just sits there and runs. So from a scheduler's point of view, actually to support Singularity is kind of no work at all. Whereas with other runtimes, it can be quite a bit of effort.
Right, got it.
In the image that you're running with these containers, already you're describing a lot of differences that we might expect from other types of containerization. Most specifically, like you're describing direct access to the GPU rather than through an abstraction layer. But it also does encryption, which sounds like an important thing for protecting the data. But how did you approach, or what does that look like in the sense, again, of a performance and security balance, having encrypted images?
Yeah, really great question. So, our image format is certainly very different from most other container runtimes. So we have our own image format called the Singularity Image Format, or SIF for short. SIF compared to, well, let's talk about the alternative to SIF. So really the alternative is kind of the Open Containers Initiative. That's a format that's, originated from the Docker space and has been standardized and kind of open since moving to OCI. With that, really the focus is on layers. So when you download an image, from Docker Hub, you're downloading usually many layers, and then you have a manifest that ties those all together. So that has a lot of nice advantages. One of them is that if you have frequent updates, but a lot of your layers aren't changing, you kind of you have deduplication there, so you're not pulling a lot of traffic over network traffic. On the other hand, though, that implies a startup cost. So in order to get a container running, what you have to do is you have to take all those layers, and they're effectively tarballs. You decompress them, build up this root file system on disk, and then once you've done all that, you can start the container. In contrast, Singularity has a very simple image format. So it's a single file, and everything that you need to use that file and verify its integrity is contained within a single file. That obviously, we're talking about startup costs. That has really nice implications. So for us, really, a startup of a container involves mounting a section of that file directly into the kernel, and that's kind of it. There's no decompression that has to happen. As time has moved on, and we've become more focused on security, that also has some nice properties there. In the OCI space, when you talk about image integrity and encryption, really what you're talking about is encrypting and verifying integrity on those layers. But of course, like I mentioned, there are steps after those checks are done that have to be performed in order to get that container running. With Singularity, on the other hand, with SIF, what we can do is we actually sign the root file system in its entirety, and then we mount. That's the exact same, the same bytes that we're mounting into the kernel. And when you start talking about encryption, it gets even more interesting because we're actually able to leverage LUKS directly. So the same technology that backs full disk encryption on Linux. When you start an encrypted Singularity container, what you're doing is just mounting with LUKS directly into the kernel. So pass the key material into the kernel. We don't have to have that intermediate step where we're decrypting each layer, building up that root file system and having to find a place to put that decrypted content. If you look on disk when an encrypted Singularity image is running, actually you'll just find an encrypted Singularity image. So that has a lot of nice properties, for people that have to protect data due to regulation or policy or whatever. This is a way that they can throw that in a container and have some assurance that data is being protected even while a container is running.
Now, does that mean from an update perspective, software update perspective, it's a little harder now because I can't replace a layer. I have to look at the whole thing together to get it back into that format, right?
Yeah, absolutely. I mean, like anything, there are trade-offs here. I will say, in an HPC context specifically, typically what happens is, you're not going to download that 1,000 times if you need to run that image on 1,000 different nodes. Typically, you're downloading that to that shared file system once, and then spawning that on 1,000 different nodes that have access to that. So it really depends on the use case, but yeah, in general, that's one of the trade-offs there of having this, a simpler image format. You don't necessarily get the same deduplication that you do with OCI images.
Which in this particular use case might be perfectly fine, right? Because you have very specific models that are going to run. If you're going to make tweaks to that model, you make the tweaks in a whole and then rerun it again. In this environment, that may be a very acceptable trade-off versus somebody who's running a web server and wants to update like a microservice sitting over here in some environment, completely different use case.
Yeah, definitely. And the other way to look at it is that Singularity from the start has always had this philosophy of integration in the container ecosystem. So Singularity itself actually does have full support for pulling from, if you want to pull from Docker Hub or even a private registry like Amazon ECR or any of the private registries, you could actually do that. So it's very flexible. You can kind of choose if and when you want to cross that boundary. We do see a lot of sites that work with Docker images where it makes sense, and then they convert them to Singularity images, when it makes sense to do so. So there's some flexibility there. You don't have to be all in on one image format or the other in order to make use of Singularity.
That's very cool. And I think that shifting a little bit, I'm kind of curious too to hear a little bit more about how have people been using it, or what has uptake been looking like? Because we heard a couple benefits of I'm going to go back to the cool part about access to the resources rather than abstracting them. The updating mechanism it seems within HPC land actually not much easier or much more straightforward. But what are some of the other reasons that developers or teams are turning to SIF to benefit either security or its enablement for their architectures?
I'm sorry, could you repeat the question? I think I'm having some challenges with my internet. I've just missed the last 30 seconds or so.
No worries. It was a long-winded question that was a bit focused on what are the ways that developers, have you seen them benefiting either incidentally from security because they're adopting SIF, or they're really looking towards this containerization has helped them in their particular environments?
Yeah, for sure. Okay, so I think really there's two key areas that we've seen. So in HPC, our roots, I think greater than 90% of the supercomputing centers in the world are running Singularity today. So that's really our base. That's where we grew out of. There are two new areas that we're starting to see a lot of uptake in. The first is AI and machine learning. So this is an area that often requires access to specialized hardware. There are a lot of technologies out there that are starting to use things like MPI. And so, these really the training side of AI looks a lot like an HPC problem. And as a result of that, we've had a lot of uptake in those spaces. That has also pulled us a little bit into the other side of AI, which is the inference side. And that tends to look a lot more like traditional microservices, where latency again is more important than throughput. And so, as a CTO looking at these things, a lot of people are trying to combine them. So, trying to do AI training as well as inference with something like Kubernetes. That is often where we enter the picture. So, somebody's tried to do that. And been quite successful on the inference side and had significant challenges on the training side, and so they're starting to look at Singularity for the training side. The other area of focus we've seen is what I like to call the connected edge. So devices that aren't in a data center, but do need frequent updates, and at the same time aren't really appropriate for full-blown orchestration. So this could, any device that's on a shop floor or on the side of a building, that sort of thing. Security is paramount there. So often these devices have, physical hardware security elements inside of them. And that makes it challenging to distribute applications in a secure way. So we're actually seeing some uptake there as well, where Singularity is a nice image format for that environment because these devices are often power sensitive. So, having a low startup cost is important to them. And with our security model, we can really take that root of trust that some of these devices have through the hardware and the OS and extend that to cover containerized workloads as well. So I think that's kind of a new area for us, and something we have a lot of partners that we're working with in that area. But yeah, I think really those are the two main focuses.
Cool. And I especially like that because it's the idea of there's an aspect to it that says you designed, a lot of these security features into the image format, but these security features have become enablement for products. So it's outside of just HPC. And that type of narrative to have security being something that makes a product feature better or is a better enablement to a product, to me, always sounds like anytime you can find that is great. And that's something where security is actually demonstrating value in this case. So that's pretty neat to hear. What about managing these? Because we did touch a little bit on talking about Kubernetes, or you also mentioned SSHing into these containers. Have there been different ways that you've approached, or different ways that you've seen customers approach managing fleets of these images, or different ways that they have introduced alternate challenges in how they want to manage all of these containers?
Yeah, for sure. I'd say we have the full gamut. Even, you mentioned Kubernetes. I think that's a huge focus for a lot of places today. We actually had a contract, and we people taking that approach. Oh, I'm sorry. And on the other side, I think there's a lot of people looking, like in this connected edge case, there's a lot of people looking for a solution in that space. I don't think there's as clear of a leader that's emerged there as there is in kind of the data center microservices, cloud native kind of case. So we are looking in that area and participating in that area. And without giving too much away, I think we will have some products coming down the road that address some of those needs. Mm-hmm. But yeah, today, I mean, there's a huge number of ways you can orchestrate or schedule containerized workloads with Singularity, and we're just kind of looking at what customers need and trying to work with the community to build that up as the situation's evolving.
So one of the things we focused on here is talking often about like secure defaults and avoiding misconfigurations. So if you had wanted to share some quick advice, or one or two items to anyone adopting SIF or approaching this, what are some secure defaults you'd highlight, or what are some gotchas in terms of misconfigurations that you'd really want to make sure people be aware of and avoid, for that matter?
Yeah, I think the biggest one is, it might seem obvious upon saying it, but you shouldn't take code off the internet and run it as root. I hope everyone here finds that quite funny.
You heard it here first.
Well, yeah, I've been saying this for like 3 years, but I still think people are catching up to the concept.
Yes, if you look, even in production in a lot of places, there are a lot of containerized workloads that start with, a base image just downloaded from the internet, slap some code in that and run that as root, even though there's no real need for that stuff to be running as root. With binding a higher port, often you can get away with just not having that run as an unprivileged user. So that's been our default from the start. That largely came out of the fact that we started from a more interactive workload basis, where people were logging into an HPC system and either running that Singularity directly or running it through a scheduler as themselves. But I think in the entire ecosystem, you're now starting to see this shift, even in the cloud native space, away from running things as root and having a bigger focus on running things with appropriate privileges. Other than that, I think it always depends on your environment. So every time you expose something inside a container, you're increasing your attack surface. So in HPC, you might not think of exposing a GPU as a risk because you're comfortable with that environment. But you need to be conscious of the the workloads you're running and the environment you're running them in, and kind of make appropriate decisions based on that. So Singularity's default model is really geared towards that interactive approach of users running it as themselves. They should be able to do whatever they can outside the container, inside the container. And then for workloads, like this example of connected edge, it's possible to kind of configure that and lock that down. So utilize more namespaces to further isolate yourself from the host, or isolate that workload from the host. And then I guess by default too, Singularity does a lot of things that block escalation. So, even just having sudo inside a container, you could consider that a vulnerability. But there are actually kernel features that you can, and Singularity does leverage that can block escalation in a lot of these cases. So, yeah.
Hey, Adam, I want to go back one sec. You mentioned a little bit talking about interactivity. I'm looking at your website around the DevSecOps area. I'm trying to get a sense of how much of this overall, the container building and the signing and the sort of the gear crunching part, is that, can you guys fully automate that? Or it looks on the website like that build happens on a developer's workstation. So is that part of CI/CD, or how are folks using it?
Yeah, there's a bit of both. So I think traditionally, if you look way back at 2015, most of the people using it were researchers. They weren't developers by trade. They were, trying to find cures to cancer and that sort of stuff. So to them, writing software and really automating things didn't come naturally. That this was a thing they had to do to get their job done. But as we move forward, we have seen this push towards, more automation, DevOps or DevSecOps, whatever you want to call it. At Scilabs, one of the focuses we've had is actually supporting that. So building up this ecosystem of services around the runtime itself, so that you can plug it into a CI/CD system. So we do have things like, we have a build service that you can use freely available on the internet, reach out and build a container. We have a container library, which forms that kind of, like a place to store your images and share images. And I will say, that there's the full gamut. I think there's still people out there manually creating containers and sharing them just in a research setting. And then there's places that, are heavily automated and leveraging those services to build things in an automated way when a Git check-in happens or something like that. So all of that.
One of the things we've learned, Adam, through some of the work that we've done with our own software at Security Weekly is never trust the images or the advice from the internet when it comes to containerization. I mean, Paul's done a lot of work in slimming down our container installations, removing dependencies that we don't need. It's not easy, though, and there's not a lot of good advice. But if you can, provide a framework that allows you to do that in a better way, I think we can build better secure code using containers, but it takes some work.
Yeah, for sure. I think like anything, right, that security is always about these layers or defense in depth. You can't tackle it at one point in the stack. Singularity can't solve all problems. And I mean, you can still put insecure code inside of it and have problems result from it. And similarly, even at the system level, you have to make sure that everything's up to date. A vulnerability in the kernel, for example, is something that we can't really protect against in Singularity very, very easily. So, I think like anything, you have to have best practices across the board, and we hope that Singularity at least can address a part of that stack.
I think coming to the end here, I want to thank you, Adam, and also am curious, over the next couple of months, is there something that we should be looking out for coming from CIF, or just something interesting in the HPC environment that you've been watching some work on?
We do have some interesting products coming. I can't go into too much detail here, but I encourage everyone to, watch our space at scilabs.io. We do have a very active community, both in Slack and GitHub and on our forums. So, I'd encourage anybody who's interested in Singularity or even just curious about what it looks like to give it a spin and jump into our community forums and reach out to us and let us know what you think.
Cool. Well, thanks again for joining us, Adam.
Thank you.
And thank you, Matt. Thank you, John. And thank you, everyone, for listening. We're going to take a quick break, and then we're going to return with our next interview segment.